other application of the op amp is an integrator. In the previous class we learned the differentiator. In the differentiator, if you give any input, then so we will get the differentiation of that input at the output. So we have seen the examples also. And now integrator is a circuit. If you give an input, then you will get the integral of that input at the output. So this is an integrator, and this will be possible to get the integral of any signal if we use the op amp. Now here only the interchanging of the resistor and capacitor will take place. In the previous differentiator, here the capacitor is existing, here the resistor. But here the capacitor will go to the resistor's place and resistor will come to the capacitor's place. So this is nothing but a low pass filter. So here we can observe, and in the same way we can do the analysis. Here 0 volts, so here also 0 volts, 0 volts will be there. So some current is flowing inside and I am taking some current is coming in this circuit. So let this be IC and this be IR. So both the currents are entering into the junction. So IR is equal to VI minus 0 by R. Next, what is IC? Current flowing through the capacitor. So this is nothing but V naught minus 0. So already we have seen that when any current passing through the capacitor, IC will be nothing but C D V naught minus 0 by dt. So flow lo వెళ్ళిపోతుంది అని గుర్తుపెట్టుకోవాల్సింది. So here CF is the capacitance. Now so IR plus IC will be 0. Leaving current అనేది లేదు కాబట్టి దాన్ని 0 చేసుకుంటాం. So here VI by R1 plus CF into dV naught by dt equal to 0. Again V naught CF dV naught by dt is equal to minus VI by R1, and CF will go to the denominator. I will write it here. So here dV naught by dt will become minus 1 by CF R1 into di. So what I want, I don't want the differential of V naught, simple V naught I want. So how I can get it? By integrating on both sides. By integrating on both sides, I will get V naught is equal to integral of 0 to t 1 by CF R1 into VI. And definite integrals ganaka తీసుకుంటే మీకు ఇంకొక కాన్స్టెంట్ కూడా దీంట్లో వస్తుంది, and that constant is going to be V naught at 0. V naught at 0. So my V naught is minus 1 by CF R1 integral from 0 to t Vi plus V naught at 0. Initial condition చూపిస్తాం. So here what is my output? Output is the integral of the input multiplied with some constant, and inversion of that constant will give the output. So here the summation of this unit step function, ఈ 2 volts ఉంది కాబట్టి some step function, ఈ step function integration will give the ramp, మీకు signals లో వస్తుంది. So the if this signal is given to the integrator input, then you will get this signal at the output. And if this is given at the integrator input, then you will get the this type of signal at the output, and this is the sine signal, you will get cos signal. So here if you give the square, so you will get this triangular phase. So this is the explanation about the integrator. So integrator, differentiator రెండిటికి కన్ఫ్యూజ్ అవ్వకుండా ఏదన్నా ఒక మంచి గుర్తు పెట్టుకొని you just try to draw the correct circuit diagram, and these are the waveforms. So this is the integrator explanation. Next.